Welcome guys. uh, this is my YouTube channel In-Trance, and we'll be discussing on various topics related to mathematics, physics, for those students who are preparing for competitive exams like engineering entrance examination and other entrance examination. And in this tutorial I'll be dealing with vectors. So vector in a simple way is the physical quantity that has magnitude and direction. So is it sufficient for those quantities to define only with magnitude and direction, and can we call them vectors? So I would say it is just the necessary condition. The next condition is it has to follow law of vector addition. Let's take an example. Number 1, we have current, and number 2, we have force. So current has direction, and magnitude, but it is still a scalar quantity. Current is a scalar quantity. Force is a vector because it follows vector addition. Let's see some very useful scalar quantities. Okay, so here we have temperature, pressure, speed, distance, mass, current, and volume. In your entrance examination, like y distance is a scalar because it needs only magnitude to define it. As that of displacement, you see here is vector quantities, right? Displacement over here, and weight, force, torque, area, momentum, acceleration, velocity is also a vector quantity. I would like to stress on area, so we'll see how this area is a vector quantity and volume is a scalar in subsequent videos on dot and cross products. We'll see how a vector is being represented. So first of all, I have prepared this content, and let's start with the geometrical representation, how we are gonna represent a vector geometrically. So here I have drawn a Cartesian coordinate system. You can see, right, red one is your x-axis, and brown color represents the y, and the green one is the z-axis. So here I have drawn a line, right? Let me put it a name. I have drawn a line OA. Okay, so OA is a line having an arrow on its head, right? So this OA can be called as a vector geometrically, and in this Cartesian form, to reach to the point A, so you need to travel AX, AY, and AZ. Okay, AX is what you have to travel in X direction. AY is the same amount, what is the amount you have to travel in Y direction. So you'll get to this point, let's call it a point P right here, and again if you'll travel AZ, you'll reach to the point A, right? So if you connect the O and A, then you will be getting a vector OA. So this is known as the tail of the vector, and this is known as the head of the vector. Okay, and here you can see we can represent it with the line segment with an arrowhead. Okay, arrow must be there in order to make a line segment into a vector. So a question may be asked like which of the following is a vector? Line segment, right, ray, or some other options will be there, so you have to tick to the ray. Okay, next, for a 3D vector, either you can represent, some books have followed the bold notation, right, and some will have an A with the arrowhead, right. Okay, so this A vector can be written as AX, which is a component for X, and AY for a component of Y, AZ for a component of J. Here you see the I, J and K, which are the unit vectors. Okay, these are the unit vectors along three different axes, X, Y and G. Fine. So next, moving on to its magnitude. So length of this line OA, this length is the magnitude of that vector A, and it is represented with modulus of A vector, or simply if you write A, then it will represent the magnitude of A. Now what will be its magnitude? By simple derivations you can come to this point. The component of X, AX squared, plus component of Y, AY squared, plus component of G, AZ squared, will give you the length of this line, right, and that will be the magnitude of A vector. Moving on to its direction. So the vector A makes an angle alpha with positive x-axis, beta with positive y, and gamma with positive z-axis. So in order to specify the direction of A, we have taken the help of cosines. So if we say alpha, it will be cos inverse AX by A, beta cos inverse AY by A, and gamma cos inverse AZ by A. So in this way we have come to know about the magnitude and directions of a given vector and its geometrical representation in Cartesian coordinate system. And that's all for today, and please comment, subscribe and like. Thank you.